Following on from our previous two videos, we still need to understand how this formula was formed. Why is it that you would get this multiply with this and this multiply with this? Let's look at our unit vector here of magnitude 1. So looking at our vector, imagine this here is 3 over 5. In the y direction is 4 over 5, and in the diagonal direction it would be 1 because it's our unit vector. Imagine now you've got a solid cuboid here. So you moving from point A to point B, you could move diagonally across in this manner, or you could move around the surface of the cube. So you could move in the x component only up to here, and then now looking at this surface of the cube, you could move in the y direction only to take you to point B. So also I need you to understand that back in high school, let's say y, this is two-dimensional high school maths here, y equals 3x plus c, in our case c is 0. If you know the gradient, let's say you've got a line here, let's say the gradient is 3, so dy dx equals 3. So we know the gradient is 3. If you get the gradient and times by this width here, then you would get the height. So if this width is 2, then you times 3, the height would be 6. So if you know dy by dx, and then in a way you multiply it by the dx, you're going to get the change in the height. So I need you to realize this. So when you look at this thing here, hang on, I know our vector is located. I placed our unit vector at the origin. The reason I did that is just so that it's easier for me to explain it to you. But in reality, it could be floating in the middle of nowhere. It could be at P0 here. But the point is, it will still have the same. It will still work. It will still work. So this point here, P0 here, could be anywhere. But for me to explain this, I want you to visualize it as being at the origin. But it could be anywhere. It will still work. So looking at this, if you are a particle moving from point A to point B diagonally like this, you could just break it up into its x component and its y components. So looking at this, imagine your vertical sheet of paper here. Take the partial derivative with respect to x. Will give you the gradient along the x plane, along the x plane. So taking the partial derivative will give you the gradient. Let's just imagine it to be something like this. So this is the gradient here. This is really the width. This is the width here, because if you look at the formula here, in a way the parametric formula for this, in a way it is 1 unit of time. We can imagine s as being time, so time ticks along like this. 1 unit of s, well, you would have moved across by this much amount. You would have moved across by 3 over 5. So look. Well, if you look at this here, if you differentiate this with respect to s, it will give you whether dx by ds equals u1 So this u1 here is really this thing here. The point is that 1 unit of s, you would have moved across by this much of an amount. Meaning, when you get this times this, you would have climbed by this much of an amount. And then looking at the y component, well, if you know the gradient with respect to y, and then you times it by dy, then in a way you would have moved this much up. So this dy would be, sorry, this block here, the combination of the two would be this height here. So you would get, hang on, let me just clear this up. So you would get hang on. So this block here, this whole block here, is this height here, and this block here is this height here. So combining the two together would show you how much it has climbed up, which is df by ds. So yeah, or you could go in the other direction. So looking at this with respect to y. So you imagine your sheet of paper like this, your vertical sheet of paper along the y-axis. You working out the df with respect to y would let's just say would give you a vector looking something like, hang on, would give you something looking like this in the y direction. So now you multiply by this much of an amount, which will be 4 over 5, and then if you get this, so this here gives you the gradient, it gives you the steepness, and then this thing here gives you the length from here to here. So when you combine the two together, if you know the gradient times by the width, then it will then give you the height. So you moving in the y direction, so imagine you're an ant, you're just looking at the back surface of this cube, of this cuboid. So you're walking around the back of this cuboid here. That will then take you to here, but then you still need to get from, remember you're traveling from A to B. So now you've got to walk in the x direction. So now you've got to walk along this surface here. So walking along the surface, you would have climbed this much of an amount. It would take you to the same place. So that would then take us to here. Okay, and then I will continue in the next video.